So guys, so I was supposed to give a talk, but I couldn't really prepare a talk. Whatever I had in my mind, I put it down on a few slides, which I unfortunately cannot show right now. But I try to get some things out of those slides. So as I mentioned, I work for Your I lead the engineering effort there. There we deal with a lot of data for recommending job options, career options to early job seekers. And so the reason why we entered into this graph domain was because we found that our data was highly interconnected. So I'm going to talk about how does a graph database solve problems with big data. So I'll talk about some common big data problems, and I'll talk about how does the graph help in solving those problems. So the overview is I'll first talk about some big data problems. Then I'll talk about why do we need a graph, or let's say when do we need a graph. Then I'll talk about some problems which have been implemented in a non-graph database environment, and how are they implemented in a graph environment. And finally, I'll shift my focus to Neo4j. So in Neo4j, I'll talk about the features of Neo4j, the advantages of using Neo4j over other graph databases, and the community part of it. So the common big data problems, as we all know, are search, data mining, text mining, some sentiment analysis, finding out, generating some analytics on a used data set, or even some predictive analysis. So these are the common big data problems. So search, we all know Google has been trying to solve and has succeeded to a large extent. It is still constantly trying to improve its search by providing some context specific search, putting some semantics to it, things like that. Web 3.0 is completely semantic, so there will be a lot of buzz around search, using search on a lot of data. Then there's data mining problems. So all these BI people, what they do is, a common data mining problem could be, let's say that an insurance company which has a lot of data, and now it has to find out that the next guy who walks in and asks for insurance, I want to detect the possibility of that guy committing some fraud with my company. So even before I give some insurance to that guy, I need to find out what is the probability of this guy committing a fraud. So for that, they need a lot of historical data, and they need to find out what is the probability of this guy committing a fraud. So that comes under predictive analysis. Then there's text mining, that again comes into classification problems, machine learning problems. So a used data set can be parsed, and some text mining can be performed so that you come up with some sentiment analysis, whether this guy is talking good about a movie, some things like what Naveen had mentioned. And of course there are analytics. So there are a lot of companies who are dealing with analytics. Let's say the most common example is Google Analytics. So whenever we use a website, the activity is tracked somewhere in Google Analytics, and it shows you a nice graph mentioning how much time did the user spend on your website, how much time did what was the bounce rate of your website, and things like that. It can go a step further, and it can even tell you, if it is combined with predictive analysis, it can tell you what are the kinds of users who might be interested in viewing your site, so that you can target your advertisements accordingly. So that comes under analytics, and all these problems can be combined together to solve a lot of other problems. So let's say a geolocation problem, where I need to find out the shortest routes, or I need to find out the best possible way in which I can get from one position to a destination. I can combine it with a predictive analysis or a recommendation engine to recommend which is the best path, or which is the path which I am the most, or it could even give you a personalized recommendation, that for a kind of person who enjoys let's say greenery or forests, what would be the best part which I could take by road to reach a particular destination. And that all depends on the past data, that all depends on big data. So all these problems are the very common problems which people are talking about in big data space. Okay, now when is it that you need a graph? Now basic analytics problems can be solved even without a graph. The time when you need a graph is when your data is highly interconnected. So when you say that there's a heterogeneous set of data, you are dealing with users, you are dealing with places, you are dealing with hobbies, you are dealing with let's say a rock band, or let's take an example of Facebook. So Facebook has pages for everything. It has pages for communities, it has pages for groups, it has pages for users. It has an individual page for each photograph that you share. So all these types are heterogeneous. So you cannot really think about mapping them, connecting them using a relational structure. It would be too difficult to do that because of all the join tables involved. So and yes, it will be highly inefficient to go through those join tables. Plus nowadays we also talk about real time. So whenever you send out a tweet, it is shown up in the search results. If you do it with a hashtag and you follow that hashtag, your tweet is there in real time. So all that is possible when you traverse your data through the graph, and it is highly interconnected. So let's say in case of Twitter, I am following a few people. Those few people are following some more people. So Twitter recommends you what are the kinds of people which you might want to follow. So all that is possible by traversing your data sets as a graph. So yeah, so that is one use case. Then the other use case, which is a subset of what I just talked about, is when you need to navigate your data. So the moment you realize that you have to navigate through your data, the most relevant example would be an LBS solution, a location-based service which needs to navigate through a lot of data and find out what is the best path which I could take out. So whenever you need to navigate your data, that is when you should know that you need a graph database there. Then you need to perform some pattern matching. So there was an interesting topic which I was speaking to one of the top guys from BMC Software Research Lab. So what these guys have done is they have come up with their proprietary database, graph database, and they are using it to match subgraphs. So let's say I have an infrastructure, I am a data center. I have several thousands of machines and several million VMs running on those machines. Now, in my past history of 10 years of service, I have come up with particular use cases. Let's say I want to host a WordPress blog. So there's a kind of infrastructure which I need. Right? I need a LAMP stack. Then there's some more complex functionality there. So I put a load balancer in front of it. I need a MySQL server at the back. So this is a topology which I built over time, and they have the past data for several years with them. Now when the next client comes in, he tells me that I want to host a WordPress blog. So I have already hosted 10,000 WordPress blogs before. So if I map all that data on a graph, and if I take the topology from the client side, that I need such and such topology, there should be a load balancer which talks to two different front-end serving nodes, which talks to a single MySQL or a MySQL cluster, and he gives you a nice diagram which is laid out in a graph. Now I can match that graph with all the graphs which are present in my system and the subgraph. So that is where the pattern matching comes into place. So that is where you will need a graph. Then again, when you are dealing with networks, so this comes in networks also. So when you have a huge infrastructure, let's say it's an MNC like Infosys, which is running a lot of workstations in the environment, and all these workstations talk to each other. Now high availability is a critical point. Let's say Infosys mailing server goes down. So there's a huge loss of business there. So they need to make sure that if one node goes down, which is the node which is most likely to respond if this guy goes down. So all that analysis can be done when you lay it out on a network, and you use that data to lay it on the graph. So I was talking to someone. I think somewhere you mentioned about someone doing it for their VMs, the Red Hat guys. Yeah. So there's already something going on around graph databases and networks. So whenever you see networks, you should know that graph database can solve a lot of problems there. And a network need not just be a physical network of machines; it could be a social network also. So whenever you want to build a social network around things, a graph database could be the best possible way to go. Yeah. Okay. Now I'll get into some basics of a graph database. So there's a nice diagram. I'll share that diagram with you. So what's a graph database? So a formal definition is a graph database is a database that uses graph structures with nodes, edges, and properties on each of them. So we all know what a graph is. So whenever you store that data, it gets stored in the form of nodes and edges. So all a graph database knows is nodes and edges. So now you have the freedom of mapping all the possible heterogeneous data that you can as an individual node, and all the interconnections between them as edges. So if you were to strike an analogy between a relational database and a graph database, so whenever you talk about a particular type of node or a particular record in that in a particular table, that becomes a node. Whenever you talk about a joint table, a particular record in that joint table becomes a relationship. So whenever two records are connected to each other, you connect them usually in the relational structure using a joint table by maintaining the foreign keys. So in a graph, you do that using nodes and relationships. Okay. So a graph records data in nodes which connect via relationships. Nodes and relationships both can have properties. So you can define properties like edge weights. You can define properties like let's say I am friends with some other guy. So let's say I am one guy and the other guy is the another node, and I add an edge and I add the relationship type as friends. So tomorrow when I want to find out all the friends of a particular person, I can just do you reach that node and you do an outgoing relationship with type friends, and you get all the friends. If you were to do that in the relational structure, you'll have to go through joins. Okay. Then a graph database also offers you something called paths. So whenever you want to traverse your data, whenever you want to run through your data sets, so you can get a collection of nodes which is a path. So what a path does is it orders the nodes. So whenever you lay the data out there on a graph database, it is scattered as nodes and connected via some edges. Now if you want to say that I want to reach from let's say this place near Chatushungi Mandir to probably university, or university is too near. So I want to reach to Magarpatta city. So I can find out a path. I can think of a path. I don't think of joint tables. So that comes very naturally in a graph database. So what I need is I need all the nodes. So let's say I can treat all the signals, all the traffic signals as those nodes. So I can find out all the nodes which I'll come across while reaching Magarpatta. So I can order all those in a particular sequence using paths. So when you run a traversal would give you a set of paths, and a path is nothing but an ordered set of nodes. Okay. Then there's another thing which a graph database gives you is indices. So it is more or less the same as how it works in a relational structure. So when you want to jump on a particular record directly without even bothering the schema, so then you define it you index that particular property. So let's say I have millions of nodes in my system, and I want to find a particular set of nodes which has a particular property. So let's say I want to find out all the traffic signals in my whole graph structure. So that's when I map all the traffic signals in an index. I declare the type as a traffic signal, and I just query the index, and then I get all the types of nodes without even traversing from the root node. So if I go by the basics, every graph will have a root node, and you can traverse the whole graph if all the nodes are connected to that root node. But just in case if all the nodes are not connected, you can go by indexes. So these were the basics of a graph database. Then I had jotted down a few examples. So let's say if I want to implement a social network. So I have a type of so let's talk about the relational approach. So I'll consider a table called users. I'll consider a table called let's say groups. I can think of pages which can correspond to a user profile, or it can correspond to a group's profile, and so on. Now if I want to connect, I want to come up with some relationships between the users. Let's say if some of the users are colleagues of each other, or they are friends of each other. So if you were to model it in a relational structure, you'll have to come up with those many types of joint tables. So let's say in a simple Java Hibernate ecosystem, I want to come up with a social network. So I'll define multiple sets, like a user dot colleagues, user dot friends, and there will be several such joint tables which I'll have to walk through. Now just imagine if I have to make some sense of like I am an employer and I want to hire a particular person. So I'll run through that social network and I'll look for the referrals. So or let's say if I want to secure a job in a particular company, I'll run through and if I want to make use of my social network. So I'll go through my social network and I'll find out employees which are with that particular organization, and then I'll get myself referred by those guys. So if I want to solve that problem, I'll have to run through several join tables. Okay. Now, what would be the entity relationship diagram look like? So there will be some primary keys, some foreign keys, some one-to-many mapping, some one-to-one mapping, some many-to-many mappings, and things like that. But if you were to map it on a graph, you'll simply lay that relationship on a graph and you're done. So I can illustrate more by showing some diagrams. Okay, so that is there. So the major advantage of using a graph database is that it comes naturally to you. You never shift, you never drift away from the business case. So if you want to establish a friendship between two users, you will establish a friendship between two users. You won't talk about adding two foreign keys or talking in primary keys. So you will always stay very close to your business case. Okay. Now let me shift my focus to Neo4j. So what exactly is Neo4j? I've been talking about Neo4j for the past few hours. Neo4j is a persistent graph data store. It does transactions in memory, but it is also capable of flushing those transactions to the disk, so that you never lose your data. Then it is scalable with high availability. You can set up multiple clusters, multiple nodes in a cluster, so that you don't lose out on high availability. It is open source. At least the community edition is open source, so you can always modify the source according to your needs. You can contribute, and it's freely available. Neo4j has a strong community support. So the reason I am here is because I am a part of Neo4j community, and it has a global community support. If you go and search for Neo4j mailing list, you will find a lot of results. There's a lot of things. So if you want to get started with Neo4j, you always have a strong community to back you. Then Neo4j has recently started off with giving out cloud support. So Neo4j guys have come up with some community AMIs for Amazon EC2, so that you can just get started with a Neo4j EC2 instance. They also offer Debian packages, so you can add a PPA in your Ubuntu installation, and you can simply do a sudo apt-get install Neo4j and you're done. Then it also offers a Heroku support. So if for the people who are familiar with Heroku, if you want to deploy something on Heroku, you always have a free add-on for Neo4j instance.
But doesn't Heroku support Postgres?
It has an add-on for everything. So it has an add-on for MongoDB, it has an add-on for Neo4j, it has Redis. So you can always take those add-ons and build your own infrastructure. So now Neo4j guys have also started supporting Heroku. So if you want to deploy an application for free on the cloud, you can always take that add-on and get started.
So one question regarding this. So this database Neo4j, where will the database go?
On the disk, on the remote instance. So what happens is...
So do I have to buy another server instance where I host my Neo4j and then Heroku will communicate with that, or?
No, then it will give you a dyno.
I think Heroku provides a hosted instance of Neo4j.
Yes.
So it's a hosted service.
Okay, so then will I have to pay Neo4j for it?
You have to pay
Heroku.
Only Heroku.
So it gives you one dyno for free. And,
no, because what I thought was Heroku was just Postgres plus dyno. No other database.
No. It supports more, but if you buy more dynos, you have to pay. For a single dyno, it's free.
Okay. Sorry.
Then it gives you, so I was talking about Neo4j. So Neo4j, now we talk about how do you query a graph database. So we all know that if you were to query a relational database, there's SQL. So in order to query a graph database, there are some query interfaces. Neo4j comes with Cypher and Gremlin. Gremlin is a de facto standard for most graph databases. Cypher is something which is being built by Neo4j. Its aim is to make graph traversals more readable and more powerful. So if you get a chance to search about Gremlin, you will see that it's a little cryptic. You will have to go through a steep learning curve to learn Gremlin. But if you want to start off with Cypher, it is an SQL-like syntax. So you define a start node, you do a start from some node and from there you do a where, you do order, you do limit, you do all sorts of things that you can do with SQL, and still it traverses the graph.
So basically using that you can traverse a graph just as easily as you can traverse a conventional database.
Yes. So,
but isn't there a downside to the same thing with
it's a little slower.
Probably it's a very trivial question, but no, for graph databases in general, should they not be slower than conventional databases?
Sorry?
Should they not be slower than other conventional databases?
So Neo4j has been able to crack that. Earlier graph databases which came in the market, they were a little slower. But Neo4j has been able to support a lot of nodes without hampering the performance. So your concern was
no performance hampering at all.
no.
How do you manage that?
Compared to RDBMS.
RDBMS, so it all depends on the data set.
Okay.
So Neo4j supports several billions of nodes in a particular instance,
Yeah.
and it is still able to do some good work. So the way to optimize a MySQL database would be to add indices on your columns. So the way to optimize a graph database is you add indices on your properties. And that's how you can optimize it.
So basically, the commodity hardware can support Neo4j for like a good startup for 6 to 1 year.
So
The community hardware can support or we can install.
So 1 year is a very relative term. It
Yeah,
depends on what kind of data you get.
I haven't slashdotted, I have been on checkerboards then.
Yeah.
1 year.
So yeah, I mean it supports 32 billion nodes and 32 billion edges. So as long as you don't exhaust that limit, and that's only because the limit of long in Java is 32 billion.
I see. But that would be possible in the commodity hardware.
No,
which I
in
can-
all of them. In enterprise, in advanced, in everything.
No. I'm not talking. I'm talking about I have a commodity hardware. Like I can buy it cheaper
Yeah.
from like that,
Yeah.
and I install that
Yeah.
Neo4j on that.
Yeah.
Would it support it for like longer run?
Yes,
Till I
yes, it will.
have enough money to buy something related.
It will. So if you get a chance to go on Neo4j website, there's a hardware calculator.
Okay.
So if you define the number of nodes and the number of properties you are expecting, approximate number, it will give you what kind of hardware do you need.
Okay.
So you can get an estimate from there.
So node and property both are stored in different entities, or both are in the same.
So
row?
I don't know the details of the storage,
Okay.
but when you query it, they come together. An advantage of Neo4j is that it is easier to set up. So if you go via the relational route, you'll need some big ass infrastructure with like a Netezza server or some complex BI infrastructure which can churn out the similar results from an SQL database. For Neo4j, you just need that community jar, which takes some memory footprint of around 750 KB or something like that. I don't know the exact number, but it's pretty small. So we are running a Neo4j instance on a micro EC2 instance. So and that serves several hundred thousand nodes at the moment. The moment we cross that limit, then we'll move on probably to a small EC2 instance. But we don't see a problem. So we are running a production instance. To give you an idea, we are running a production Neo4j instance on an EC2 small instance, and currently it is serving some 700,000 nodes and 2.1 million edges, and still without a loss of performance. It still runs at 50% CPU load. So yeah, I think it is pretty good.
If I ask you to recommend a visualization library which is most compatible with this, what would you say?
So people have done some good work with D3.js.
Sorry?
D3 is one library which people have worked with. So they've been able to render all that graphics with. So all these visualizing libraries, most of them rely on JSON.
Right.
So a big feature of Neo4j is it gives you the graph database over a REST interface.
What about Jephi?
Jephi, GFFI,
Yeah, PHI.
GPHI. I didn't get a chance to look into that.
But that is supposed to be JavaScript, right?
Yeah.
Okay.
So people are using Neo4j with Jephi.
Okay.
So what it does is it gives you a REST interface. So you don't really bother about the intricate details of a graph. All you do is you make REST calls and you get REST response. So if you are expecting a JSON response, you just get a JSON response and it will start working. So you have to modify your JavaScript to consume that JSON response.
Right.
And that's it. So yeah, and the community edition is free to use. So that is another advantage. You can always go out and play around with it. Around the community, there are several frameworks which are supported by the community. They are being maintained by the community. Major platforms like Java, Ruby, Python, even Clojure, Haskell, Lang, you name the platform and there's a framework which supports Neo4j. And people are constantly maintaining it actively and upgrading it with every milestone of Neo4j. One interesting thing so there's a guy called Max Demerzi. So what he has done is he has built a Ruby wrapper for Neo4j over REST, so that you can use that wrapper to access Neo4j for any Ruby application. It could be a Rails application, it could be a Sinatra application, and you can use this wrapper to talk to a Neo4j server over REST. So he has also come up with a very nice batch importer for an SQL database. So you give it an SQL dump, you take a MySQL dump from your existing database, and you feed it to that batch importer. It will render it on the graph. And so that you can directly import your SQL database to the graph and you can get to it.
What about Node.js? Is there any?
Yes, there's a wrapper for Node.js with Neo4j.
But just one question, how will it know what is a node and what is a edge when it is imported?
So it will read the join tables. It will go through the join tables and it will read the primary keys of that node.
Okay.
So there's some configuration required, and there's a there's a blog post also. So if you want to go through that, I can point you to the blog post.
So basically it is so good at what it does because it can read the join tables so nicely.
The batch importer.
The batch what?
Batch importer, which is written by the guy. So that is only done. So because a major hurdle which people find is for a legacy software which was written with an SQL schema structure. If you want to replace it with a graph database, it's a huge task.
Yeah.
So that's when this batch importer comes into picture. You can directly import it, and of course there will be some tweaks required here and there. I don't know if it's 100% efficient. I've never tried it, but what I can see is there's a utility which you can use and you can get going without even bothering about how you're going to support the legacy software.
Do you think because of this particular feature it can go a long way in simply optimizing internet traffic and this sort of things?
You never know.
Because
people
obviously it will take a lot of time and a lot of effort.
Yeah. So people are already using it on production. People have started using it for a lot of things. So I personally I'm taking efforts in growing the community in India. So I've been in talks with ThoughtWorks guys. So ThoughtWorks people have done several projects with Neo4j for US clients. So there are already people using things in production. We use it in production. We've been using production for 1 year. So probably we are the only people in India who are using it for an Indian product in production. So yeah, I mean, and Neo4j has been there around for the last several years, and now it has started gaining pace because it has a strong community support. So that if you stumble upon something, you always have a lot of people to back you. So yeah, as a part of the community, we organize meetups every month. So typically, third Saturday of every month is a Neo4j India meetup. Then we also have some coding sessions. We had organized a boot camp for Neo4j beginners. So if you wanted to get in touch with Neo4j guys, we can connect you there. There are open office hours which are organized by Neo4j team. So what these guys do is they host a Google Hangout or something like that. So you can directly get in touch with Neo4j team, people who have built Neo4j. And of course there are a lot of mailing lists which you can subscribe to and you can get your doubts cleared. So one important thing which I wanted to demo was if you guys can go through console.neo4j.org. You can point your browsers to console.neo4j.org. So what it has given is, it has given a cloud interface for running Cypher queries on the cloud. So it's nothing but a Heroku instance of Neo4j, a hosted Neo4j instance on Heroku, and you can directly run real-time Cypher queries on that. So if you want to save yourself from the hassle of installing Neo4j, which I think is not a hassle as such, but if you don't want to install Neo4j, you can always refer that console.neo4j.org, and you can go through. You can read around. There's a tutorial. There's a small tutorial there by which you can go and add nodes. You can add relationships, and you can play around with it. Any Game of Thrones fans here?
Game of Thrones, you said Game of Thrones?
Yes. So you can go to console.neo4j.org/GOT and you'll find the Game of Thrones hierarchy rendered on the graph. So all the families, Lannister family and all the houses. So those are mentioned. Those are mapped on the graph.
Console.neo4j/GOT.
Yes.
Small caps.
Doesn't matter. You can see URL.
Doesn't matter.
Okay, can you try the query parameter ID equal to GOT?
Console.neo4j.org/GOT.
So apparently /GOT is not working. You could try a query parameter id equal to 0 key. Let me share that on the IRC.
So on the console.neo4j.org, are they using
They're using hosted Heroku Neo4j.
They have this relationship. They have this graph floating around, right?
Yes.
So it's a DC graph or what are they using?
I don't know exactly what
It's
they are.
.org/r/GOT.
Oh, is it?
I think so. And Google says that.
Yeah, friendly URL is /r/GOT. So what they've done is
Query parameter is also working, by the way.
sorry.
The query parameter is also working.
So what they've done is they've populated some master data and they've mapped some relationships. So you can run some nice traversals on the graph if you want. There's a tutorial. If you click on the small eye icon on the top right, so you'll get a small tutorial of how to create an edge, how to add a node. You can get started from there. So I wanted to know, has anyone ever considered a graph database before for any?
Yes. So for this, so for when you have a so the problem statement that I was working on was this. It was an MIS for microfinance institutions. I talked last time about it. So the problem that occurs is even these MISs have to figure out how to give loan, the credit rating of a client. And most importantly, what happens is currently we store all that data in MySQL because it's a financial software. So when it was designed. So the way it was designed was all the data was stored in MySQL, including the financial transactions as well as client data. So as far as client data is concerned, we were thinking about using graph databases, not just as the relation about clients, but when clients are related to each other.
Okay.
So in that fashion.
So like the social network of those.
Yeah. So yes, the social network of the, and that will decide because if you look at the business case itself is that if a client is creditworthy is decided by his relations to his neighbors.
His credibility.
Yeah. Exactly. So that's how it is. So, but we could never actually do it. We considered doing it, but there were like we had to run the business also and stuff. So we really did not have. But yes, we considered doing.
So there was a very nice quote in one of the Neo4j webinars which I had. So what it said is, a relational data store can tell you what are the salaries of people sitting in this room, what are the names of people sitting in this room, what percent of people earn at a certain higher level. A graph database can tell you which person is the most likely to get you a beer. Get you a beer. So relational database might fail in that. Graph database can actually pinpoint which is the guy who can take you out for a dinner or something. You can have beer.
Exactly. So what we were basically aiming for was something like graph plus RDBMS. RDBMS is purely to store the financial data. And so if there are any examples, and you can point them in which people are using two different types of databases to solve just one problem.
We are using a MySQL database and
so MySQL for what?
For one-to-one lookups. So like when there is a plain lookup, you go with the MySQL. So let's say I know the user, so I don't need a traversal. So I just go and look up the MySQL database.
Okay, yeah, but in this case it is like, I guess your stuff must be the same data that you're storing in your graph database is getting stored in MySQL.
Some of it is exclusively on the graph, some of it is exclusively on MySQL, some of it is on both. So
Why?
Okay,
Should say
okay, I guess
only Marathon stands for.
But even
Why should they drop
Can you
closer?
take a few more questions and then close?
Sure.
Please, so that the video
happens is this guy, these two guys, right?
So are there any questions?
On the Ruby wrapper for the Neo4j, so every query would be a REST API call to the Neo4j.
It's called Neography. Anyone wants to go?
What is that?
Neography.
What's the maximum amount of data that you guys are handling? I mean, I understand there's a billions of nodes and edges.
So right now we are doing 700,000 nodes and around 2.5 million relationships.
So the amount of data I'm asking is
like the memory footprint. So what happens is when you store it in Neo4j, it stores it in memory. Whenever the memory size goes beyond a certain limit, it flushes to the disk, and it does it incrementally. So when you store a Neo4j when you store data on the Neo4j database, it will take incremental iterations on that data. So the kind of memory footprint that you get is in GBs. Like if you ask me, we are doing somewhere around 26 GB of memory footprint, but that is more of an incremental data. Like that, so let's say 1 month before I had 100,000 nodes, the next day I got some more nodes. So that is for easier backups. So let's say if I upgrade my community version tomorrow to enterprise, I get a capability of doing online backups. And if I want to restore my database, it will look through the incremental logs, and it will just play those logs incrementally. So first it will add the first 100,000 nodes, then it knows that the next day more 100,000 nodes were added, things like that. So that is the information which is being stored. If you ask me about the data, so there's a way to compress that also. So that can be, so that 26 GB of data can be reduced to 22 MB. So I can store that much of data, like 700,000 nodes and 2.5 million relationships in about 30 MB of data.
Actually, I also wanted to know about the disk size. So it's like, can I put like, I'm not sure about what you're trying to explain. So if I have to like store terabyte of data in Neo4j, so obviously I'm not querying all that data, right? But if I were to run a group by, it might run on that terabyte size data.
Right.
So how much it can handle in terms of terabyte? Because I won't have terabyte of RAM, right? Right. So how would that work? Or what will be the amount of data I can push in?
So there's practically no limit to it. The performance would definitely go down as soon as you start increasing your data. It will hit a certain limit, right? It happens with every kind of database. So if you hit a particular limit, the efficiency goes down. Then you have to take some measures, like you need to index the data and things like that. So you could always index your 1 terabyte of data in index, and you could do and yeah, one more thing is Neo4j supports Lucene. It uses Lucene as its index store. So you can do a full text search using Lucene indices. So you could actually do a search autocomplete kind of functionality using Neo4j.
Do we need to refresh the Lucene index whenever the changes happen?
Yes, so that is one way, and Neo4j also supports auto indexing. If you set an
Neo4j flushes to cache only or flush to disk only if it reaches a certain memory limit. What happens when your server crashes in between?
So that particular transaction which was there in memory, which was ongoing right now within the REST calls, only that is damaged. Whatever was there before it, whatever is in there in the memory, you lose that. But that happens with any in-memory data store.
Right.
What it offers is it flushes it in particular intervals. So as a backup measure, what we usually do is we have set up a cron job to run every night, which just restarts the Neo4j side.
So it will flush to disk.
It will flush everything to the disk. So even if we lose something, we can roll back to the last day's changes.
So like you are achieving the eventual consistency this way.
Yes.
But there is no concept of eventual consistency like MongoDB has it.
No.
So how consistent it would be if I'm using it and I can't have like luxury of having the cron jobs running.
So like I said, that if the server crashes, whatever is there in the memory, you lose that much. Whatever was persisted before that, you can always.
Do you have the data elsewhere?
Elsewhere
as in the data that you have inside Neo4j, is it only in Neo4j? What I'm saying is, if you lose it, can you get it back? Is it in a MySQL data store? Is it on
the backup?
Yeah, exactly. As in
the backup in other traditional
that's what I'm
form of data layer basically.
Okay. So by backup, usually people take MySQL dumps.
Right.
From a MySQL.
Or you take a full backup of the MySQL data files.
Okay, the disk.
Yeah.
So you could do that with Neo4j also.
No, that's not what I'm asking. What I'm asking is that you've reached a point where your server is crashed. Whatever was in memory is lost.
Okay.
So do you have the data elsewhere?
On the disk.
No.
The only memory part.
No.
Okay, let's say I would
The incremental backup.
let's say you are shutting
Sorry,
down the
sorry.
Neo4j server where the data will be stored meantime.
Yeah.
That is the question.
No. My question is, your data store is in memory, right? But in a traditional database, you're always writing to disk. Neo4j, that's not happening.
It's writing to disk in specific intervals.
Exactly.
Yeah.
So if you're losing the data in between, is the data elsewhere in MySQL or is it not available to you anywhere else? In the sense, I'm asking about your particular setup.
Okay.
Do you not have the data anywhere else, or
So what do you mean by losing the data? I mean, when the server crashes, I still have my EBS wallet.
How much data will be needed?
what about the data that was not flushed to the disk?
That probably I lose.
Yeah, like I'm asking if you have the data elsewhere. That data.
So that even
are you
that
storing
is
it
not
in
lost.
MySQL so that you can replay it back, or
Some of it would be there. So what we are doing is we are gathering some user generated content, and there's some master data.
Okay.
So all the nodes which are more central. So when you talk about a graph, you talk about the most central nodes.
Right.
So centrality is defined by the number of connections it has with other adjacent
Right.
nodes. So what we have done is whatever nodes we know that are going to be very central, highly central, we are replicating that data on MySQL also.
Okay.
But what you lose when Neo4j crashes is the relationships which were being created in that during that
span of time.
Right.
This is the graph database. Like we have like 30 million nodes into the base in this graph. And suppose we delete some of the middle node. So whole graph will refresh below graph. Right. So how much time does it take to reorganize the whenever we delete any intermediate node?
So what do you mean by reorganization?
Suppose we add some node in between, or we delete some of the thing, then the other nodes will take in the place of the node, and others in the memory or in the disk, or everything will be shifted to the other.
So I don't know the details of how it is stored on the disk, but if you want to consider a graph, so when you lay your data on the graph, there are several nodes which are connected to each other by relationships. Now if you have A connected to B, connected to C, and if you remove B, so now you are saying how is it rearranged? So what it does is whenever you remove a node, it removes all the edges associated with that. So A and B.
That is quite easy operation if its map is very like millions of data is there.
Doesn't matter. It only has to bother about that node and its incoming or outgoing edges. So it will just get rid of the edges connected to that node.
If I understand correctly, what they are asking is that MySQL databases or any other conventional databases have a fair amount of redundancy in them. So how does Neo4j compare with that?
So redundancy, what do you mean by redundancy?
As in, we have replication of data and all that, right?
So,
To compensate for loss of data.
yeah, so how do you exactly replicate that?
In MySQL.
Yeah.
So you
have
use-
master
slaves.
you put up a cluster.
You have master, you have
Yeah, you have a master slave array.
So same thing is possible.
So same thing is possible with Neo4j also.
And what about sharding?
Sharding is not possible with MySQL. Not at the moment. So what Neo4j gives you is a high availability solution. So there's a community edition, there's an enterprise, there's an advanced edition, and there's an enterprise edition. So advanced and enterprise can give you high availability. So what it does is it keeps a zookeeper arrangement where you have a master which is talking to a lot of slaves, but all of them are exact copies, exact replicas of each other. So it's not sharding actually.
It's replication.
Yeah, it's replication. So whenever
Sharding is
one
basically like he said, like these are terabytes of data, and you want to query it again.
Break it down into chunks.
so
You can have
the
the
distributed
faster
data.
query. Let's say all the data related to the continent Asia is somewhere else, if North America is somewhere else. So you know that it is not going to overlap, or there will be no connection in between.
There could be some connections, but
No, let's say your business cases as that there is no connection.
then I'll store it in separate independent graphs. But if there are some connections, then sharding comes into picture. There was an interesting project in the Neo4j community which came around about a couple of days back. It's called GraphPack. Someone has implemented a sharding mechanism using Neo4j. So what he has done is he has put up a lot of Neo4j instances at the back, and there's his GraphPack solution talking to all those Neo4j instances and maintaining subgraphs on each of those. So I'm yet to try it. Still, it looks like it's in the concept mode right now. It's not yet commercial or released.
And it is transaction ready. I mean, how how much I can rely on the application. I mean,
Yeah.
of course, you told
So you can achieve transactions which are yeah, it is transaction. When we do what we do is we use Gremlin for our queries, for read, writes, traversal, everything. So Gremlin supports transactions. So you can start a transaction, you can put your execution in that block, and you can end that transaction. So if something goes down in between, it can roll back.